Good evening to everyone. So, my name is Dr. Chitrakuludi. So, today we are going to discuss the problems on Thevenin's theorem. So, in the last class, we seen about Thevenin's theorem. So, in that we covered. So, what is the statement of Thevenin's theorem? So, what are the steps has to follow in order to determine the equivalent circuit of Thevenin's theorem, as well as how to find the load current by using Thevenin's theorem. So these things we seen in yesterday class. So what are the steps we followed in the Thevenin's theorem? The same steps we are going to use here. So in order to draw the equivalent circuit as well as to find the current through the load also. So today we are going to see the problems on Thevenin's theorem. So the first problem, the first example. So find the Thevenin equivalent circuit for the network in the dotted area of the network of figure. Then find the current through the 10 ohm resistor. So this is the network they given. So in that network, so what they are asking that they are asking to calculate the Thevenin equivalent circuit for the network in the dotted area. Okay, for this dotted area, they are asking to draw the Thevenin equivalent circuit, as well as they are asking to find how much current is passing through 10 ohm resistor. So that is the load resistance they are asking. So solution. So if you understand the problem, so that we can write the given data. So for any problem, first we have to understand the problem, what data they given, what they are asking in the problem, that we have to understand very clearly. So once if you understand, from that we can do the problem so easy manner. So here the given data is, so in the problem they are asking Thevenin equivalent circuit. So the Thevenin equivalent circuit is the question mark. And also they given find how much current is passing through the 10 ohm resistor. So that is current through the 10 ohm resistor, that is I10 or IL equal to question mark. So these two we have to find in this problem. So in order to find the current through the load resistance, so what are the steps we have to follow? So what are the steps we followed in the Thevenin's theorem? So the same steps we have to follow here also. So the step one is to determine the current through the load resistance, that is RL. So for that, temporarily remove the load resistance, that is 10 ohm, the load resistance 10 ohm from the terminals A and B. After removing the load resistance from the terminal A and B, so that network is shown in below here. So this is the network after removing the load resistance. So we remove the load resistance here. So the step two is determination of Thevenin voltage. So how to determine the Thevenin voltage? So first find the open circuit voltage, that is VOC, as well as we can call it as a Thevenin voltage between the terminals A and B. So when you are calculating your Thevenin voltage, so in order to make it all the sources, that means whatever the sources they given in the problem, that sources you keep it in original position. You could not change anything here. So that figure is shown here. So in this figure, we are going to calculate the Thevenin voltage between the terminals A and B. So if you observe this figure, it having one closed loop, one open loop. So in the above figure, the 3 ohm and 6 ohm resistors are connected in series. So then the resistance is 3 plus 6 equal to 9 ohm. Why? Because this 3 ohm and 6 ohm are connected in series. That's why 3 plus 6 equal to 9 ohm. So according to the Ohm's law, I equal to V by R. So here we know the voltage, that is 9 volts they given. So now we are identified the equivalent resistance, that is 9 ohm we are identified. So if you substitute here I equal to your voltage is 9 as well as your total resistance is 9. So 9 by 9 is 1 amps. So the current flowing through this loop is 1 amps. So whatever the current is passing through the R1, the same current is passing through the R3 also. Why it is passing the same current? Because R1 and R3 are connected in series. So now the current through the R3 is, that is I3 equal to 1 amp. So therefore the voltage across the R3 is, that is V3 over R VTH is equal to I3 into R3. So now we know the V3 value as well as R3 they given. So what is I3 value? I3 is 1. What is R3? So R3 is 6. So 1 into 6 equal to 6 volts. So this is the Thevenin voltage. The voltage across the R3 is the Thevenin voltage. What is the Thevenin voltage here? VTH equal to 6 volts. So what have we done so far? First we removed the load resistance. So in the second step, we are identified how much Thevenin voltage. So in the third step, determination of Thevenin resistance, that is RTH. So you want to calculate the Thevenin resistance. Where you are going to calculate the Thevenin resistance? So the Thevenin resistance of the network, that is the Thevenin equivalent resistance of the network. So seen from the terminals A and B, that is shown in below figure. So this is the network they shown. So but when you are calculating this Thevenin voltage, so we have to make it some of the steps. That means if any voltage sources are there, those voltage sources we can make it as a short circuit. If any current sources are there, we can make it as a open circuit. So if you observe this figure, 3 and 6 ohm are connected in parallel. So in the above figure, 3 ohm and 6 ohm are connected in parallel. So then the resistance is 3 into 6 divided by 3 plus 6, that is equal to 18 by 9 equal to 2 ohm. So now the current is, now the circuit is, so this is the 2 ohm because the 3 and 6 ohm are connected in parallel. So here if we observe that, so this 3 ohm 6 ohm replaced with the 2 ohm resistor. The 2 ohm resistor is connected in series with the 2 ohm resistor. That circuit is shown here. So 2 ohm resistor in series with the 2 ohm resistor. So in the above figure, so in this figure, 2 ohm and 2 ohm are in series. Now the Thevenin resistance, that is the Thevenin equivalent resistance, RTH equal to 2 plus 2 equal to 4 ohm. So now we know the Thevenin voltage as well as the Thevenin resistance. Once if you know the Thevenin voltage, Thevenin resistance, so we can draw the equivalent circuit of Thevenin's theorem. So in step 4, draw the Thevenin equivalent circuit. How we can draw the Thevenin equivalent circuit? By replacing the entire network, what they given in the Thevenin's theorem. So that we are replacing with the Thevenin voltage in series with the Thevenin resistance, that is shown in below figure. So the Thevenin voltage in series with the Thevenin resistance. So how much voltage we are getting here? Thevenin voltage 6 volts. In the step 2, we are identified the Thevenin voltage, that is 6 volts. So in the step 3, we are identified the Thevenin resistance, that is 4 ohm. So from that, we drawn the Thevenin equivalent circuit. So in step 5, so initially we removed the load resistance from the terminal AB. So here what we are doing means, where we remove the load resistance, that load resistance we are connecting back to its original position, and it is shown in below figure. So initially we removed from the A and B terminal. Again we are connected that load resistance to the this AB terminal only. So in step 6, determine the current through the 10 ohm resistor, that is your load resistance. Okay. So if you observe this figure, RTH and RL are in series. Okay. According to the Ohm's law, I equal to, that means here IL equal to VTH by RTH plus RL. So we know the VTH value, that is 6, by we know the RTH value, that is 4, as well as we know the RL value, that is 10. So once if we simplify that, you will get 0.428 amperes. So this is the current through the load resistance. So in the problem, they are asking how much current is passing through the load resistance, as well as they are asking to draw the equivalent circuit. Those two already we done. So even though we are doing in step 7, the potential difference across the load, that is VL equal to IL into RL. That means the drop across this one, the voltage drop across the load resistance, VL equal to IL into RL. So now we know the IL value as well as we know the RL value. So from that we are going to calculate how much voltage drop across the load resistance. That is VL equal to 0.428 into 10. Here 0.428 is the IL, 10 is the RL. So that is equal to 4.28 volts. So this is the voltage drop across the load resistance, or else the potential difference across the load resistance. So this is the first problem with the Thevenin's theorem. So in coming videos, we are going to see the number of problems with the help of Thevenin's theorem, how we are going to solve the number of problems upcoming videos. So thank you.